For us humans, vision is our most important sense. We depend on vision in almost everything we do. It is essential for manual labor, from tasks big to small, picking to placing, or assembling and handling tools. As technology continues to evolve, robots will perform dull, dirty, and dangerous tasks rather than humans, contributing to a society that provides a better life for people. One of the enablers for this is the emergence of vision for robotics.
Welcome to Zivid, and thank you for joining us today. Zivid is on a mission to provide human-like vision to robots. 3D vision for industrial robot cells working in factories and warehouses, doing picking, placing, assembling, and handling tools. With our fast-evolving 3D camera offering, we help our customers create robot cells that can handle an ever-expanding range of tasks. By enabling robots to work faster and be more flexible, we help maximize productivity. Finally, we make it easier for our customers to deploy robots at scale with higher uptime and less maintenance needs. At Zivid, we're super proud to have many customers leveraging our camera for a broad range of applications. Within warehousing and logistics, for piece picking, parcel handling, and depalletization. Within manufacturing, for bin picking, machine tending, assembly, welding, and surface finishing. We engage deeply with our customers as true and trusted partners in their endeavor to create robot cells. Zivid is fully committed to the 3D camera, not attempting to compete with our customer. We deliver 3D cameras that help our customers push the envelope of robotic automation. Only last year, we released the Zivid 2 Plus, the world's first 3D camera able to image transparent surfaces. It represented a true game changer for our customers, in particular within piece picking, where the 2 Plus enabled them to pick a whole range of items previously impossible, making piece picking viable at scale. We are fortunate to work with some of the most ambitious, capable, and demanding customers in our industry, constantly challenging us with their needs and requirements. To that end, we have a new camera to show you today. Today, we are introducing the 2 Plus R. With this new camera lineup, we set out to help tackle the following 3 changes faced by our customer. Firstly, speed up the cycle time of the robot without compromising on the type of object it can handle. Secondly, increase effective pick rate in real-world production environments, minimizing mispicks, double picks, damages, and drops. And thirdly, optimize cost and simplify the robot cell. We're here to tell you more about Zivid 2 Plus R and our latest SDK today. To do so, I have brought along some of the key people behind this new camera. Øyvind, product maestro at Zivid. Are you excited?
Hell yeah. I am. It's been a lot of work leading up to this moment, and right now I just can't wait to get this camera out in the hands of customers and see what kind of applications they can do.
Okay, let's start off talking about perhaps the most challenging application for vision systems, piece picking. What does the new 2 Plus R have to offer?
Up until now, a major limiting factor for how fast the robot can work has been camera captures. And anything above 250 milliseconds is going to hurt the cycle time. So with the 2 Plus R camera, we can capture really challenging scenes, including transparent objects, in 150 milliseconds. And that is 3 times faster than the previous benchmark, which was the Zivid 2 Plus. With this camera, we're basically not going to limit the speed of the robot, and that's really huge. In addition, I think what many tend to forget is that the cycle time of the robot is also affected by how often it makes mistakes. For example, failing to grasp an item, dropping it, damaging it, picking two at a time, for example. All of these things have a huge negative impact. What we've also done is that we have improved the quality of the point clouds and the 2D images and made them more robust to ambient light. What this results in is that the robot will then have a reduced chance of making mistakes. And this also benefits the cycle time.
You mentioned 2D.
Yep.
What's the deal with the Zivid 2 Plus R and 2D imaging?
Yeah, so the 2 Plus R has a 2D camera, which is gonna make a big difference for AI-based segmentation. So what we learned over the years is that changes or variations in light intensity on the production floor, especially for piece picking, can have a huge impact on how they perform. So basically these light changes, they impact how the 2D machine vision algorithms basically perform. And what's common in the industry today is that you use a lot of illumination, like we have in this room here right now, and the shades and whatnot. They basically then try to limit the variations of this light intensity in order to keep the images as stable as possible. What we decided to do with this camera was to basically tackle this problem head on and completely reinvented the 2D camera. What we achieved is a self-illuminating 2D camera with remarkable immunity to variations in ambient light intensity.
It's pretty cool and I think important for the performance. So what does the built-in 2D camera means for the overall cost and complexity of the cells?
Well, because we consolidate the 2D camera into the same device, there's really no need for extra 2D cameras, illumination. You can reduce a lot of cables, mounts, simplify network switches, power management, and so on. It's really possible to make these robots really lean by deleting a lot of redundant parts worth thousands of dollars, really. So yeah, we found that we can help reduce the cost and complexity of the robot quite a bit, actually. At the same time, we can help boost the capabilities and performance by a lot.
Is this camera for piece picking only?
Not at all. It's super versatile, really. And that's really great for me because I get to work with all these customers out there that make applications in all these different segments and areas. It's kind of like living inside a How It's Made YouTube channel, so it's pretty good. Today we are releasing 3 models of the Zivid 2 Plus R. The 3 models that we have is, first there's the MR60, which has a very wide field of view, but short focus distance, and it makes super crisp point clouds. It's really ideal for assembly, welding, some inspection, surface finishing tasks, and a couple of other robot guiding applications, especially when you mount it onto the robot. And then there's the big sister, LR110. This one also has a wide field of view, but double the focus distance. With this camera, you get really super performance over a wide area, which makes it very, very efficient. In piece picking, for example, you can use it to cover 2 bins at the same time. Or if you mount it on a robot, it's super great for a lot of bin picking applications in manufacturing or depalletizing. And the third camera is the MR130. So this workhorse is really optimized for looking at standard totes from a distance while it's hanging stationary, giving plenty of clearance for the robot to move under it. It's really the ultimate 3D camera out there today for really demanding pick-and-place applications like piece picking, bin picking, and parcel handling.
Parcel handling, you mentioned parcel handling. This is an application with pretty extreme speed requirements. 150 millisecond captures in parcel handling that's actually long, right?
Yes, we got something really cool in store here, actually. We got down to 50 millisecond capture times of any parcel. Basically, that means that our customers can build parcel induction and sortation robots that operate at 2,000 pics per hour, really. And they get all the same benefits as our piece picking customers. So the 2D functionality, the 3D functionality, the ability to simplify the robot cell, and the performance really hits the mark for making really productive and scalable robots.
Let's talk a bit about applications in manufacturing, like bin picking, machine tending. There's highly reflective, shiny metals. More often than not, the customer is relying on CAD-based detections. What do we have in store for them?
Well, so first off, the 2+R is a lot faster also for manufacturing applications. Here, there's a lot more variation in what kind of hardware the camera is interfacing, but the acquisition time is a lot faster, about 4x. In addition, because this camera is so fast, we can use the time we save to basically refine the results and provide even higher quality point clouds than before. That makes these robots able to handle much more challenging parts than they've ever done. And today, we're also releasing a brand new 3D reconstruction technology. It deals with some really nasty reflections so that the 2+R can handle extremely shiny materials that you've never handled before.
The robot cells that our customers create, they're complex. Some are more complex than others. Significant engineering time and effort will go into simply getting these cells working. What are we doing to help?
In my opinion, as engineers, we spend way too much time fixing stuff that we shouldn't spend time on when making robots. These machines should be up and running much faster and smoother than they do today. You know, every sensor that you have in there is going to cost hours and hours to get up and running. They all come with their unique sets of problems. For example, one thing that fascinates me is that it's just become sort of universally accepted that whenever you use a 2D and a 3D camera together to provide information for guiding a robot, you should just use a lot of camera calibrations and approximate lens models to do transformations between the two domains and all that kind of stuff. Well, with Zivid, you don't need to do that. Every camera is factory calibrated, both the 2D part and the 3D part. Basically, this ensures that every pixel to point is perfectly mapped. Hook it up, write a few lines of code, run some hand-eye calibration, choose a preset, and off you go. We can help you save hundreds of engineering hours so that you can move on to the next project or next problem rather than wasting time on stuff that you shouldn't do. Our goal here is really to help our customers make more scalable robots that work more reliably and can be replicated and managed with as little effort as possible.
So you're fortunate to spend a lot of time out with customers. So given what you see out there, do you have any advice or thoughts to those customers building these cells?
The vision system is a super critical part of the robot together with the gripper. And very often, it's the limiting part of the system as well. Frankly, from my perspective, you need some performance margins on your camera. I know myself that it's super easy to underestimate all these unknown unknowns, and yeah, we all do that. But after working with a lot of customers over the years, my advice is basically this: get yourself some performance margins. Otherwise, you run a real risk of spending way more time than you anticipated fixing things to make it work. You run a real risk of failing the acceptance test because the performance just isn't there. I mean, the most important thing is for the robot to do valuable work. Otherwise, it's just a waste of time and money.
Let's shift gear a little bit and talk about cost. There's definitely lower cost cameras out there. Yet at the same time, a lot of our customers that have deployments at scale, they tell us that the Zivid cameras are very attractive from a cost of ownership perspective. How is this so?
Well, at the end of the day, what you pay for is the robot doing work. We already spoke about cost savings that you could do in the cell, but The 2+R also makes the robot more reliable, and more capable and more productive, so that you can give it more work. This means, for example, for bigger deployments that requires many robots, if you can double the productivity of a single robot, you can cut the number of robots in half, and that saves the total cost. With simpler and fewer robots, you also get less maintenance work you have to deal with and less downtime you have to manage. Nobody really likes dealing with downtime or maintenance except business people that charge for it. Operators, engineers, we all hate it. Indeed, these cameras are really attractive, not only from a cost perspective, but because of the value that they generate.
That's some good points. So we're going to look at some point clouds.
Yes, actually. We're going to head over to Camilla, who's going to show us really what this camera can do for a bunch of different applications.
Great, let's do that.
We are joined here by Camilla, who's going to show us how fast and how good these point clouds can be created by the Zivid 2+R cameras.
I am super excited to show off our new amazing cameras. So my job is to write software that gets the most out of our cameras, and the hardware in the 2+R has really sparked innovation and opened a lot of doors to the vision team. Today I want to start out with showing you this bin right here, which is filled with random consumer products that you could find in a fulfillment center. So you have some transparent, some translucent, some shiny metallic stuff, a bit of everything.
Yeah, so this would be for piece picking, right?
Yeah, you're absolutely right, David. Up here I have mounted the Zivid 2 Plus MR130, and I'm going to show you what the 2D image on point cloud looks like in Zivid Studio. So as I said, we have a bit of everything in this bin, and if you go into 3D, you can see that we have these transparent surfaces that are resolved nicely without ghost planes or collapses. We have this shiny metallic wrapping right here without any reflection artifacts. Over here we have some bubble wrap, which is typically very noisy, but this is resolved nicely and smoothly.
So these point clouds look really amazing, right? You got these apparel inside plastic bags and transparent bottles and lunch boxes and whatnot. And obviously these surfaces are totally pickable for a robot. But what about the capture time?
Let's recapture and see. So the capture time now is about 150 milliseconds. So with the Zivid 2 Plus, this was about 450 milliseconds, so we are 3 times faster than before. That means that this camera can see everything that's inside a fulfillment center in record time, even if the robot has never seen any of this before.
So we're not going to limit the speed of the robot, and we're not going to limit the kind of inventory that it's going to be presented with or look at, which basically means that at the end of the day, with this camera, these robots are going to work faster, they're going to be more capable, and they're going to be more productive.
You're absolutely right, David.
Super cool. Let's move over to an application that works even faster. Let's go to parcel handling, where they do induction and sorting. So those guys, they need to pick at rates of 1,000 to 2,000 picks per hour, which is almost like 1.5 seconds per pick. So what do we got in store for those guys?
The Zivid 2 Plus R is actually able to capture in sub 50 milliseconds, which will definitely let you do 1 pick per second. In parcel handling, it's easy to think that that's simple because it's just parcels. But as I will demonstrate with this scene here, we actually have a bit of everything there as well. So I brought some cardboard, some white packages, and some of these shiny black materials, which are really, really hard to get. So not only do you have to capture in a very limited time, but your camera needs to have an impressive dynamic range. I'm going to demonstrate this to you now, again with the MR130.
Okay, let's have a look.
So as we see, we are again able to resolve all these surfaces nicely and continuously, and we do so in only 40 milliseconds.
40 milliseconds, that's pretty incredible. So these robots are certainly going to be able to pick really, really fast. So for parcel handling, we can then deal with any kind of parcel, and for piece picking, we can deal with kind of almost any kind of inventory, do it at the speeds that they need to do. Let's move to the other side of the application spectrum. Let's go to manufacturing and look at what we can do for those guys over there.
Yeah, manufacturing is quite different with different challenges, but I think those customers will also be excited about the 2+R. So on the production line, it's all about precise execution. If the camera is not able to provide the precise location and size and shape of objects that it's seeing, the robot is going to fail. Therefore, I have brought this bin here to illustrate what the MR60 can do in a manufacturing setting. So here we have some very shiny materials. We have these metallic cylinders. They're a classic benchmark in 3D imaging. You often get these specular highlights on top that causes contrast distortion artifacts, which are very nasty. And we also have some other metallic parts that you will see in the point cloud.
So what do you have here, Camilla?
So to a 3D camera, this is a very challenging scenario as the light will be bouncing all around the place. When we look at the point cloud, we see that the MR60 is able to resolve all these objects very correctly. We get a lot of correct points on top of the cylinders and on the other metallic objects without any artifacts. The reason this is so important is that in manufacturing, you often want to do CAD matching. And the better your point cloud is, the more you can tighten in your precisions in your CAD matching algorithm, giving fewer false matches and letting you have fewer missed objects.
All right, Camille, so that's great. But typically, manufacturing applications don't really require the same types of speed as we see in piece picking or parcel handling. So can you just remind, for those who are looking, why this matters for manufacturing customers?
Many of our customers mount the Zivid camera onto a robot arm, which is a super alternative to mounting it statically above the scene. When you have that flexibility, you can get the camera up close to the objects you are looking at, giving you higher resolution and higher precision. When the Zivid 2+R is 3 times faster than before, it drastically reduces the amount of time the robot spends by stopping and imaging and starting again. This means that robot mounting becomes viable for more applications than before.
Great. All right, so that was a very impressive and difficult showcase of what the 2+R can do on challenging items. But I also happen to know that we actually have 26 customers that have challenged us to address even more extreme materials with even more reflections in them.
I know what you're talking about, David, and I have brought the bin here to illustrate this blue, shiny, terrible bin right here, filled with shiny things. I'm going to show you how this looks with our previous camera model, the Zivid 2 Plus M60. So if you start out by looking at the 2D image, you can see that this is almost like a mirror. You can clearly see the vertical reflections that are going to cause issues for the camera. And if we go into the point cloud, these 2 objects here, close to the bin wall, are just completely destroyed. You have this disc here, which would definitely not be recognizable by a CAD matching algorithm. Probably not the cylinder either, and even if it was recognized, this ghost plane here would stop the robot from picking or interacting with it. Reflections in general are a huge challenge in 3D imaging, and in particular, vertical reflections are almost impossible to solve for structured light cameras. I am therefore thrilled to show you our latest and greatest innovation, the Sage engine. Last year, we were the first to solve transparent surfaces with the Omni engine. Now we are doing it again, and we are the first to solve vertical reflections with the experimental new Sage engine. So let me show you what this looks like with the MR60 and the Sage engine. If we look at the point cloud now, the reflections are gone. This would be identifiable by a CAD matching algorithm, and this would not be hindering the robot from interacting with the object.
It's crazy to see how we can resolve these super hard reflections. But I also happen to know that the Sage engine is actually pretty good for something else as well. Because we do have a lot of customers that use, for example, hole detection to help their robots figure out what to do. For example, for solving ambiguous orientations or helping out with some alignment. So can you show what the Sage engine can do in this case?
Absolutely. I brought an example to illustrate this as well. So here I have a bin filled with shiny materials which have very fine details. This disc, for instance, you would only be able to determine the orientation of if you were to detect these little screw holes and alignment holes on its interior. We also brought some screws, which often the robot wants to pick up and identify as screws.
Yep.
I'll show you how this point cloud looks with the Sage engine because it can definitely help you here.
All right.
As the Sage engine is extremely conservative about what points it leaves and recognizes as valid points, you can get very fine details with high confidence. Here you can see that you would be able to recognize holes on this object and also on this one. And you can even see the threads on the screws over here. Yeah, so this is a very nice point cloud, just beautiful.
Wow, that's really incredible, Camilla. So to see what you guys have been able to achieve and the kind of quality and speed improvements that you've been able to do on top of this hardware is just remarkable. Next up, we're going to head over to Sam, who's going to show us how we're doing on the 2D camera side and what we did there for the 2+R. So thank you, Camilla.
Thank you, Øyvind.
Hey Sam, glad you can join us here and show us what this 2D camera is all about.
I'm always excited to show off these cameras, Øyvind.
Let's start on these warehousing applications. So for piece picking and parcel handling, the 2D image is really important for the robot to prioritize which objects to pick and so on. Obviously, the time it takes to get the 2D images matters a lot. So could you explain a little bit what we've done here to help our customers?
Yeah, we attacked this challenge directly. So with the 2+R, you get the 2D capture very fast. And this means that we can actually give the user the 2D capture before the 3D point cloud is even processed. And this is a huge head start for AI segmentation or template matching. That can get underway while we are wrapping up the point cloud. Then you can get on to pose estimating before you're even done the 3D capture. That's just talking raw speed. But there's also a lot of speed performance to gain in your cell if you have a high quality 2D capture.
Can you elaborate a little bit about what you mean when you say high quality 2D?
Yeah, absolutely. So in order for your AI segmentation to not make errors and be as accurate as possible, what you really want is for your 2D capture to be as close to the ground truth as possible. So there's sort of three challenges here. The first one is, can you resolve fine details? The second one is, can you get rid of these camera-specific artifacts? And the third and final one is, can you make it image-to-image stable across varying ambient light conditions? And we actually completely redesigned our 2D camera in order to combat all three of these challenges in a completely new way.
Fantastic. So can you show us?
Yeah, absolutely. So we have two of our models here. We have the Zivid 2 Plus M130, that's our older model. We also have the Zivid 2 Plus MR130, that's our newer model. So we have some difficult objects for high-resolution 2D cameras, and I'd like to show you a comparison between the Zivid 2 Plus M130 and the Zivid 2 Plus MR130.
All right.
And so let's go take a look here. Let's take a capture, show you that this is real. And when we zoom in here, you can see that we have these high-frequency radial lines. In particular, if you look at the M130, or older model, you see that we start to lose resolution as we move towards the center of this target. If we then take a capture here with the MR130, we end up getting extremely high resolution as we move towards the center of this target. It's limited only by the pixel pitch of the sensor. So what's important to note here is both of these cameras have 5 megapixel sensors. But with our clever redesign, the effective resolution of the MR130 is much higher. And so one thing that you'd notice is that really their ability to resolve fine details, it's tied with whether or not you have these camera-specific artifacts. For instance, in here, you can see that the debayering algorithm is leading to this sort of zipper effect, especially in various colored scenes. So we can look at other objects here. For instance, look at this deck of playing cards on the MR130. That is crazy. There's really high colored details here, and we see everything. We see the text. You can see the lines within the leaves here. It is greatly washed out when you look at it on a similar 5 megapixel camera. And then let's go and look at something maybe, I love these tee boxes, they're so colorful. We look at this tee box over here. What does our comparison look like on the MR130? Wow, that's just night and day. I mean, you could pick out these symbols here. You can pick out trees and leaves on the trees, and the colors are very strong.
And that's with 2 cameras that both are 5 megapixel.
Absolutely, yeah. Just a redesign of our camera.
And this is going to greatly help template matching algorithms to resolve different sort of textures that look similar and so on. That's why we're kind of looking at this, right? So
Yeah, the underlying thread here is if we can give you a closer to ground truth image, then your AI segmentation algorithm, it doesn't need to work as hard. You don't need as many complex training sets, and you can identify key features much more easily.
all right, so you have shown us that this camera can produce some really fine, detailed 2D images. But what about this image-to-image stability you were talking about?
I'm really glad you asked, because this is the fun part. Oyvind, if you may, can you go over here and control this light box here?
All right.
What I'd like to show you is as we increase the intensity of the ambient light, which is going to be from these 3 light sources, that the image stays extremely stable with our new 2+R model.
Okay.
So let's see. Right now we have very little light. I'm going to start live capturing. So this is the quality of our image. We can see there's some tiny amount of shot noise changing, so this is a real capture. Let's go turn up the lights.
All right.
Okay. So now I actually have a lux meter over here that says we are at 700 lux. That's way above what you'd expect in a normal warehouse. And look at this. We have great colors, extremely strong colors, and it looks almost identical to what we previously had before. So let's go all the way up.
All right.
Oh, I guess we're there. We're at 1600 lux. I didn't even notice because it looks so good on this film. Fantastic. So what I'm really showing here is that this camera is extremely robust to being in different warehouse environments. Whether you have one cell that has a little bit of lighting or another cell that has an extreme amount of lights, we're going to give you the same 2D image.
So what that really means is that a specific product or object, for example, that green box there, is going to look identical to 2 different robots in 2 different warehouses in 2 different lighting conditions.
Absolutely, and that's extremely important for AI segmentation, because then it doesn't have to work as hard to give you the same result.
Are there any other sort of light intensity considerations that we should be aware of?
Absolutely. So the color temperature of your ambient light can play a huge role on what the colors are in your scene. So for instance, if I had a lot of orange or reddish light, then objects would end up being more red. So if my AI segmentation thinks my box is green, it better look green in my 2D image. And in fact, we can show that with a really fun example here. We have to bring the party.
Okay, so how do we do that? Yeah.
And so now we have an extreme version of color temperature varying in the scene. So we're going all the way from a pretty strong blue to a pretty strong red to a strong green. Actually, if we look at the lux meter, we're around 1,000 lux in almost all these scenarios. Yet this is our point cloud. So to prove that this is actually our point cloud, I can zoom in and we can see that there is some shot noise variation. We can perhaps look at these checkers, and you can see maybe ever so slightly that the intensity is varying between the checkers, but not the color. What I'm showing now is that the camera is extremely robust to changes in color temperature across different warehouse conditions.
That's just incredible, Sam. Thank you so much for a fantastic demo. Is there anything else that you want to show us?
Yeah, let's take a look at the point clouds. Are they having a good time at this party? So we can come over here. Let's go take some 3D captures. So here, again, this is extreme lux values of 1200 lux, and we have beautiful point cloud coverage even across this varying color temperature scene.
So no changes to the 2D colors, no changes to the intensity, and no changes to the point clouds, including this transparent object that we got in here.
Absolutely, that's the power of our new 2D camera technology here.
That basically wraps up, Sam, how powerful this camera is, both from a 3D perspective and from a 2D perspective, with both from all this point cloud quality that we've shown, all the speed, and this ambient light robustness. The next thing we want to do is go over to Christian, who can show us how our customers can take this camera and get it up and running as fast and smooth as possible. So thank you, Sam, for the great demo.
Thank you for having me.
As one of the best application engineers we have in Zivid, you spend a lot of your time sharing your expertise with customers as they're about to start a journey to bring up all these fantastic robots that they're trying to build. Given that we're actually launching a product here the way that we're doing, I think it's a really good opportunity for you to just basically share your knowledge to a broader set of audience. What do you have in store for us?
Yeah, this is actually the new camera, the Zivid 2 Plus R series. And for those who are familiar with our existing products, it looks identical. Yet, I mean, as we've seen here today, we packed a lot of new technology into this same thing, basically. Design is quite elegant. It has this elegant look, but at the same time, it is robust and it's built for these harsh industrial environments. It can withstand shock, or it's capable of withstanding shock and vibration and robot accelerations. At the same time, it's also then suitable to be mounted stationary or on the robot itself without taking up too much space or hurting the payload. Inside of here, we take advantage of active cooling to ensure stable performance across all temperature variations. It also helps to prevent overheating, which is a common problem with passive cooling.
Basically, all of these innovations that we've shown today are inside of that camera, not outside. So basically, the housing and the fit of this product is the same as with the other Zivid 2 Plus models that we had from before, which is going to make it very simple for our customers to adopt to these new 2 Plus R models, I guess.
Yeah, exactly. Because the housing is the same, it means that all the customer can reuse their accessories, such as cabling, mounts, and protective housing. And yeah, as you've been saying, it makes it easier to transit to the new cameras, basically.
Good. So that's the hardware. Now, what about the software side?
So on the software side, the 2 Plus R series will be supported by our new SDK 2.14, alongside with our existing 2 Plus and 2 Zivid 2 cameras. So I actually have underneath here, I have a small Jetson PC that I thought we could test out the new SDK on. What's nice is that our SDK works on Windows, Ubuntu, and NVIDIA Jetson or Jetson ARM architecture. So I thought it would just be nice to try out something else and see how easy it is to work with any operating system.
So first, for those who have been using Studio before, you may see that we're giving it a facelift with a more compressed and elegant design. Secondly, we added very neat region of interest tool to make it much simpler to define your region of interest, where you can drag your borders and you get some visual feedback as well. Thirdly, is that we have redesigned how the 2D and 3D settings work. And with this mode, you can now use the same settings for 3 different capturing modes. If we go to the 2D button and we capture, we'll only get the 2D image. In this mode, you can choose to output your data in color or grayscale. You can independently tune your exposure settings, and you can also select the resolution depending on what your algorithm needs. Going over to the 3D, if you do this capture, you only get the 3D data without any colors. If you're not depending on the color information, this will speed up your capture even more. Lastly, we have this 2D plus 3D mode where you get both the color and the point cloud together. We are optimizing the synchronization and pipelining this under the hood, so you don't have to think about that. We know that most customers within robotic machine vision applications, you typically process the 2D image first. So in this mode, we're going to give you the 2D image right after that's done, while we in parallel are computing the point cloud. This means that for the customers, they can actually start doing their, for example, 2D segmentation, and when they need the point cloud later on, it will be ready for them. And speaking of getting kind of exceptional data, we define a set of presets that we carefully designed for different applications. Now, since we're connected to the MR130, we can choose between presets such as consumer goods tailored towards piece picking and warehouse automation. We have manufacturing that is tailored towards industrial bin picking type of application. And then we also have parcels for the logistics. Just to give an example here, since we do have a piece picking scene in front of us. Just going to use the consumer goods fast. I'm going to capture, and as you may see, we get perfect data, both on the point cloud level, but also on 2D. The combination of this new way of working with 2D and 3D settings with the presets makes it super simple to use our cameras, and I'm pretty sure even my grandma will be able to use it now. But then you can ask the question, how do we go from studio to working with this programmatically? Because most customers, they will implement our SDK within their own software. So first, let's just save our settings to a file, and we're going to show you. And then you disconnect the camera. Let's just open one of our examples from our GitHub or Python sampler repo. And this illustrates how intuitive and easy our API is to work with. So with these lines of code, we're initializing the Zivid application, we're connecting to the camera, we're loading in the settings that we just saved, and from there we are doing the 2D 3D capture. After that, we'll extract the color information and the point cloud information. And if we were to run the sample, we're gonna see that the camera is gonna flash and we're gonna capture, and we're left with the point cloud or all the information basically as a ZTF file. And at last we can just drag and drop this into our studio here, and we can look at the results. I would say, as expected, we still have this exceptional 3D data. The color information is still intact. And as we can see on the right here, we have a bit of metadata, but also all of our settings that we just defined. That's it, actually. That's how easy it is to work with our cameras.
All right, so this looks really straightforward, Christian.
Crazy how simple it is to use our cameras, actually. And it's built by developers for developers. And we do get a lot of good feedback from our existing customer that our SDK is easy to use and very intuitive. And we do take a lot of pride in that, actually. And I just want to mention that our SDK also includes other features such as hand-eye calibration to further help our customers along their journey with our cameras. We do have tons of sample code on our different GitHub repositories, and we do have extensive tutorials, tips and tricks in our knowledge base. So I think our goal is to make our customers' life as easy as possible so they can focus on innovative development instead of doing these tedious hardware setups.
That wraps it up very nicely. So thank you very much, Christian.
Oh, thank you for having me.
And with that, I think we're going to go back to Thomas and wrap this all up. Hey.
Hey, that was super cool, Øyvind.
Yeah, I know.
So we're getting to the end. Very important question. What is available when for our customers?
You know what? We've actually already stocked up a lot of these cameras, and we're ready to start shipping to customers today. As a matter of fact, we've actually already shipped hundreds of these to a few selected customers. And we've been ramping up the production line to get ready for this day. You can also find the SDK on zivid.com, together with tons of other resources like sample code, knowledge base, data sheets, and so on. And I know that our sales team are super excited to get out on the road and show the 2+R off to new and existing customers out there.
Thank you, Øyvind. So in short, with the Zivid 2+R, we help speed up the cycle time of your robot without compromising on the type of object it can handle. We increase the effective pick rate in real-world production environments, minimizing mispick, double pick, damages, and drops. We optimize cost and simplify your robot cell. It's available today. Cameras are on stock. They're ready to ship. Thank you for watching and joining us today.